This lesson is on probability tree diagrams and looking at conditional probability on tree diagrams for combined events. This also shows you your equipment list that you'll need for this lesson, and some of the keywords that we've looked at already and that we'll be going through this lesson. Things like and or when we come to multiplying or adding the probabilities, and looking at dependent and independent, and when we've got a conditional or unconditional probability. So for the first part, we need to look at what are dependent events. So in the context of probability tree diagrams, a lot of the questions will be things like you've got a box containing items and you take one out, or a bag containing counters and things like that. Dependent events are where we need to think about what's happened previously. For example, if you remove a counter from a box and you do not put it back, then therefore you've got one less counter in the box for the second time that you pick another counter out. So that's going to affect the probability because you've got one less. So that's the key thing. So the key part for this is read the questions, and you need to first part understand whether the items being removed have been replaced or not, because if they're not being replaced, therefore they'll be dependent, and that will affect the probability for the second or subsequent parts for the question. In this example, we've got a box that contains 7 black balls and 3 white balls, okay, and we're told that ball is taken at random from box and it is not replaced. So therefore, okay, this is now going to be a conditional probability. So therefore, when we draw the tree diagram, the second part will have one less from the total. So okay, so first part, I'm going to complete the tree diagram before I look at the questions. So for this first part, there's 7 black. So the first part of the tree is already done for me. So 7 out of 10. So therefore, there'll be 3 out of 10 for the white balls. And then for this next stage, for the second pick, what we need to remember is that because there was 10 at the start, I've taken out 1 black. So therefore now there's 9 in total. And there was 7 black at the start, so therefore there's now 6. So for the white, there's still 3 out of 9 white that remain in the box if I follow this path. And then if the first ball that I picked was white, then there'll still be 7 out of the 9 that are black, but then there'll be 2 out of the 9 that are white. And then once I've done the fractions or the numbers on the tree, I can write down all my combinations. So here it can be black and black, black and white, white and black, and then white and white. So okay, so those are all the different combinations that you can have. And so looking at the complete copy and complete the tree diagram to show all the possible outcomes. So those are all the outcomes. So for this part, work out the probability that the balls will be black. We need to follow this path, black and black. So okay, 7 over 10 times 6 over 9. So working out the probability is 7 over 10 times 6 over 9. 7 times 6 will give me 42 over 90. So for this is equal to 42 over 90. The 2 balls are the same color, so that what we're looking for is black and black, or white and white. So white and white will give me follow this path, so that's 3 over 10 times 2 over 9, which is equal to 6 over 90. So okay, and if I want, so for this, it'll be black and black, so 42 over 90, or 6 over 90, which gives me 48 over 90. And again, for the last one of each color. So I need black and white, or white and black. So I can follow both paths. Okay, so that's 7 out of 10 times 3 out of 9 is equal to 21 over 90, or 3 out of 10 times 7 over 9, which is again 21 over 90. So for this part, it's 21 over 90, or 21 over 90, which is equal to 42 over 90. So what I would like you to do now is pause the video, try this question for yourself, copy and complete the tree diagram, and then answer these two parts for the question. Once you've done, play the video, and then I'll go through the answers. So for this question, first part, we need to add the total number of marbles. That will be 5 plus 3 equals 8. So it's out of 8, so that will be 3 eighths for the green. That's 3 out of 8 green. And then once we've taken one out of the reds, there'll be 4 over 7 left and 3 sevenths still left, and 5 sevenths for the reds, and then 2 sevenths for the green. So that's tree diagram complete. And then again, we've got all the outcomes. We've listed all the different possible outcomes, and working out the probabilities, multiplying them across as we go. So I worked out all the 4 probabilities. Work out the probability that he takes out takes different colored marbles. So different colored marbles will be the red and green, or green and red. So just these 2 probabilities. So add them together, and you get 30 over 56. For the last part, looking at choosing a marble that's at least one of them is green. So we're looking at red green, or green red, or green green. So these 3 probabilities, we add them together and we get 36 over 56 as the answer. In this example, it reads, Karen has a bag of sweets. A bag contains 2 toffees, 3 fruit and 4 mint. So now we've got 3 options to pick from, and she picks at random a sweet and eats it, and then she picks a second sweet from at random. So what this implies is that there's the sweet is not replaced. So therefore, this is now conditional. So first part, okay, of your tree diagram should look something like that. So it's got 3 options, and those are your 2 picks. So that will be your first pick, your first option, and then your second. And then for this, contains 2 toffees, 3 fruit, and 4 mint. So this will be for toffees, and I've just used the letters there: toffee, fruit, and mint. And again, that'll be toffee, fruit, and mint for the second options: toffee, fruit, and mint. So that will give me all the combinations. And then for the probabilities, 2 plus 3 plus 4. So there's 4, 5, 6, 7, 8, 9. So the first part, they're out of 9. So there's 2 toffees, so that's 2 out of 9. And 3 out of 9. And the mints, they're 4 out of 9. So that'll give me the probabilities for the first pick. Then for the second part, because she eats the sweet and it's not replaced, so therefore the second part, the fractions will be out of 8. So because she eats one of the toffees, so therefore there's only 1 left there, so 1 out of 8. And there's still 3 out of 8 for the fruit, and 4 out of 8 for the mint. For if she picks out, if she was to eat a fruit, one of the fruit sweets first, there are still 2 of the toffees left. Then there'll be 2 of the fruits left, and then there's still 4 of the mint. And again, if she picks out the mint, therefore again it's out of 8. From the 8 that are still there are still 2 of them that are the toffees. There are still 3 of them which are the fruits, but then there will be 3 out of the 8, so therefore the mint has gone down by 1. And then again I can write down all the combinations. So that's the toffee, so having 2 toffees, toffee and fruit, toffee and mint, fruit and toffee, fruit and fruit. So fruit and mint. And again for the last one, mint and toffee, mint and fruit, mint, mint. So now I've got the tree diagram drawn with all my combinations for the outcomes also written down. So for this next part, write down for part A, what is the probability of both sweets are toffees? So for toffee and toffee, will be following that path. So it'll be 2 over 9 times 1 over 8. That's 2 over 9 times 1 over 8, which is equal to 2. 9 times 8 equals 72. So that is equal to 2 over 72. Work out the probability that both sweets are the same. So therefore we're looking at toffee and toffee. We've got that already for the probability. Or fruit and fruit, which is equal to 3 over 9 times 2 over 8, which is equal to 6 over 72. And we also need to have the option of the mint and mint, which is again 4 over 9 times 3 over 8, which gives you 12 over 72. So for this answer, we've got, so we need to add the three values. That's 2 over 72 plus 6 over 72 plus 12 over 72. So then that gives me 12 plus 6, 18 plus 2 is 20. So that's 20 over 72. So probability that both sweets are the same. So that'll be true. Toffee and toffee, fruit and fruit, or the mint and mint. Now for the last part, I can work out probability that she chooses at least one mint sweet. So for this part, okay, if I go down the options for the outcomes, I'm going to look at all the ones that I've got the mint, at least one of the mints. So here we've got toffee and mint, fruit and mint, and then here we got mint and toffee, mint and fruit, mint and mint. So we're going to we need to work out 4 more. Okay, we've got this one already, so we need to work these 4 out. 8 over 72 plus 12 over 72 plus 8 over 72 plus 12 over 72 plus 12 over 72. I will end up with 52 over 72, and again I can leave my answer as that, okay, without simplifying it. What I would like you to do now is pause the video and copy and complete this tree diagram using this information in the question here. Once you've completed the tree diagram, play the video and I will go through the answers. So for this tree diagram, first part, you need to look at this missing value here, which is if there's 3 circles, 4 squares, and there's 14 counters in total, so therefore there'll be 7 out of 14. For the first part, if I remove one of the circles, so there'll be 2 out of 13 left, 13 triangles, 4 out of 13 squares. So the triangles and the square amount stay the same, just the denominator changes by 1. Same here, same for the second part. For the triangle, I've removed one of the triangles, that becomes 6 there, 3 and 4 again for the circle, and again 3 out of 13, 7 out of 13 for the circles and triangle, and then the square, if I've taken 1 out here, then I've got 3 left there. So that's your completed tree diagram. Same here, same for the second part. For the triangle, I've removed one of the triangles, that becomes 6 there, 3 and 4 again for the circle, and again 3 out of 13, 7 out of 13 for the circles and triangle, and then the square, if I've taken 1 out here, then I've got 3 left there. So that's your completed tree diagram. Next, what I'd like you to do now is use this tree diagram and answer these 3 questions. Again, pause the video and try the question. Once you're done, play the video and then we'll go through the answers. So for this question, probability of choosing two circles, 3 over 14 times 2 over 13, and that gives me 6 over 182, and that can simplify to not 3 over 91. Second part, probability of choosing one circle and one square in any order. So what that will look like is you're looking at circle and square here, following this path here, 3 over 14 times 4 over 13, or you could have the circle, the square followed by the circle. So you're looking at both of these probabilities and adding them together, and you'll should end up with 24 over 182, which is the same as 12 over 91. And lastly, what is the probability of choosing two of the same shape? So that will be circle, circle, triangle, triangle, or square, square. You've got three probabilities to work out. Add them together and you'll end up with 60 over 182, which is equal to 30 over 91. For the main task of this lesson, I would like you to do any two of these questions from the red section and two questions from the green section. That's two from the red, two from the green. So 4 questions in total. Making sure you draw your tree diagrams out, show all you're working out for your probabilities. And once you've done your answers, take a picture of your work and upload that onto class charts for you to have completed the work for this lesson.